question 16, we have projectile motion with an angle. So in this question g is 9.81 meters per second squared, so that's 3 sig figs. That is how our answer should be too. So a particle is projected with an initial speed of u at an angle of 35 degrees above the horizontal. It lands at point 10 meters vertically below its starting position. The particle takes 1.5 seconds to reach its highest point of its trajectory. Part A wants us to find u. So first up, let's make a little sketch. So this is the sort of thing that we've got going on. Now we know that the angle at the start is 35 degrees. Now we're just going to think of the horizontal as x and the vertical as y. And then we know that velocity can be broken into component parts. So, for example, so we're looking for u here. So, u is our initial velocity. Now, we know we got an angle of 35 degrees, so we can break this up into the vertical component, which we would call u, y, so our initial vertical velocity, and our horizontal velocity, which we would call u, x. So what we can get from that is that sine 35 is equal to uy over u, which gives us that uy is equal to u sine 35, and we can do something very similar for ux. So we know that cos of 35 would be ux over u, which tells us ux is equal to u cos 35. How was that useful? Well, we'll see in a moment. So, we also know that at the maximum height here, so let's call this m, so at m, we know that the vertical velocity vy is equal to 0, because we're not moving up or down, and we know that t is equal to 1.5, and we also know acceleration. So acceleration is gravity, so the acceleration in y is minus 9.81. It's negative because it's pushing us down. So if we go to that, can we find an equation linking v, t, a, and u? Well, yes, it's this guy right here. V is u and a t. So we know then that v y is u y add a y times t. Now at m, vy is equal to 0. Now we know uy, from what we did at the start, is a u sine 35. So 0 is a u sine 35 minus 9.81 times time 1.5. Therefore, if we add the 9.81 times 1.5, we can get that u is 9.81 times 1.5 over sine 35. Now that to 3 sig figs gives us 25.7 meters per second. Cool. B wants us to find the total time that the particle is in flight. So, what do we now know? We know that at the end of its journey, s is minus 10. We know u is, well, we now know the actual initial speed. So we know what this u is. So that's 25.7. So the initial speed in y is 25.7 sine 35. We know that our final speed or velocity is going to be 0. We know that a is minus 9.81. And what we don't know, what we want to find is t. So the equation that we're going to use is this guy, the top one. So we get minus 10 is equal to ut, so 25.7 sine 35 times t minus 1/2 80 squared. So minus 9.81 over 2 times t squared. So if we find those numbers, we get minus 10 is 14.7 t minus 4.905 t squared. It's quadratic. Get everything on the same side. So 4.905 t squared minus 14.7 t minus 10 is equal to 0. Use the quadratic formula. So t is minus b, so that's positive 14.7 plus or minus square root of b squared, so 14.7 squared minus 4ac. Now that's going to be add, because c is negative. So that's going to be add 4 times 4.905 times 10 all over 28. So all over 2 times 4.905. Now we only need to worry about the positive square root. The negative would lead us to a negative value of t, which makes no sense. So what you should get from that is that t is 3.57 seconds. Cool.